Hello everyone, Miss O'Brien here. Sorry I couldn't be there today, but you have this video to help you with your notes, which you should have pasted or taped into your notebook on, I guess that was Thursday was the last time I saw you guys. So you should have that out, and if you don't have it out, go ahead and take it out now, press pause. There might be several times throughout this video that you need to press pause just to kind of keep up, and just be aware of that. So let's get started. First, I'm going to talk a little bit about this diagram here. So, in this diagram, you see that you have two parallel lines, and we note that lines are parallel by putting these arrows on here. So, I've got this set of arrows and this set. I'm just putting them on both sides, so like people have multiple opportunities to see that they are parallel. And then if you had other parallel lines, so let's say if I had this line and this line, now those are also, let's say, parallel, but they are not parallel to my original first set of lines, these guys right here. So I'm going to put different sets of arrows on there. So I'm going to put like sets of 2 arrows on there and 2 arrows on there. So that's how we would note that. This is not the best pen here, but that's how I would note that for something else. So with that being said, that's kind of how we talk about parallel lines. So I'm not really sure why that's not using. Okay, so we'll just leave those guys there. So I've got my two sets of my set of parallel line, and I am going to go ahead and name those. I'm going to name them line A and line B, and we'll call this guy down here the line C. And the line that crosses the two parallel lines is called the transversal. Okay. So we're going to be talking about these set of properties that happen when we've got a line crossing two parallel lines. And we also have a special notation to talk about lines being parallel to one another. And we say it's A is parallel to B. Okay? So, that's kind of where we're coming from. We also have notation for inside and outside lines. We call this guy right here from everything from here and here the interior. Okay, so this is in the interior of our parallel lines, and everything else is in the exterior. So make sure you have that labeled on there too. Exterior. Okay. And then finally I'm going to go ahead and I'm going to put some angles inside there just so we have some way to talk about them. So I'm going to call this angle 1, this guy angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. And I would, if I were you, I would even go ahead and take a colored pencil or something and kind of mark everything inside here in the interior. So go ahead and do that, colored pencil, highlighter, something like that, just so you know that this is all in the interior and that this was all in the exterior. So I'm going to take maybe my green here and then talk about everything on the outside here being part of the exterior. So all of this guy is in the exterior. So again, I don't have colored pencils. I don't really have a highlighter for this guy. So this is the best I can do. The last thing I want to talk about is some of you guys already probably even noticed this in this diagram, that some of these angles look remarkably similar. And you are correct. We do have a lot of congruent angles here. In fact, we know angles 1 and angles 4 are congruent. Without any other information, we know those are congruent. And the reason why? Anybody know the reason why those are congruent? Well, it's because they're vertical angles. And we also know angles 5 and 8 are congruent to each other. And in this case, because the lines are parallel, we know they're congruent to angles 1 and 4. So right now we have angles 1 and 4 and 5 and 8 are all congruent to each other. And we're going to talk more about how angles 4, 5, 1, and 8 are all related a little later. And then I've also got these other angles. I'm trying to think of what color to use. Let's go with purple. Angles 2, 3 are vertical angles, so we know they're congruent. And 7 and 6 are also congruent angles because they're vertical angles. And they also have a special relationship. So those are just some of the things I'd like you to get marked in there now. I would use different colors to have those different markings in there because we're going to go around and now start defining some of these. And having these all labeled is very important for when we do examples later on here. Alright, so now we're ready to start talking about examples. So alternate interior angles. When you guys are thinking about that, you should be thinking about that word interior. So we know they're going to be in the inside of those parallel lines. They're going to be inside this part right here. Now when we're talking about alternate, we're talking about different sides of the transversal. So we're talking about this guy right here. I can't really do it very well with this pen. I'm talking about this guy right here on this side, and I don't think you guys can see that. This guy right here on this side, and then this guy out here on this side. So in our example, we've got angles 3 and 6. And angles 4 and 5. Okay, those are alternate interior angles. In the description here, you're going to need to write this down, so you might need to pause it, is that they're inside the parallel lines. Remember, this is our notation for parallel, and on opposite sides of the transversal. Okay, which makes sense, right? Alternate interior angles, they're inside, they're in the interior, and they're on alternate sides, opposite sides of the transversal. Now we have these theorems, and all these theorems say that if, and you should write this on top, if we have two parallel lines, and a transversal, I'm going to run out of room, but that says transversal, then we know these things are true. This first one is called the alternate interior angles theorem. So I'm going to try to squeeze that in there. The alternate interior angles theorem. Okay, so a lot of abbreviations there. Okay, but the alternate interior angles theorem says that alternate interior angles are congruent. Okay, gotta know that notation there. So again, that means congruent. And again, this is the difference between the definition and a theorem. So the definition are just angles inside parallel lines and on opposite sides of a transversal. The theorem tells us that alternate interior angles are congruent. Moving on to our alternate exterior angles. Our examples here, again, we're thinking about alternate exterior. So on different sides of our transversal, so if I'm going back up here, here's my transversal. They're going to be on opposite sides, and they're going to be on the outside. So this guy and this guy are alternate, opposite sides of the transversal, exterior angles. So if I look back to my diagram, which you guys should see up above, I'm going to have angles 1 and angles 8, and angle 2 and angle 7. Our description's there, you should copy that down. And again, we've got a theorem here, and this is, shocker, called the alternate exterior angles theorem. And that says alternate exterior angles are congruent. Okay, and again, this is all assuming we have two parallel lines and a transversal. So keep that in mind. If the lines aren't parallel, we don't know this information right here. Next, we've got corresponding angles. And this one is less obvious as far as the name goes, but they're very important. They come up all the time. And they're angles always in the same location as you slide up and down the transversal. So if I'm looking at my example here, let's see if I can pick like a bright yellow color here. If I take this angle right here, right there, and I slide that angle down, it's going to correspond to this angle right here. So in your example, we have a lot of corresponding angles. We've got angles 1 and angles 5. We've got angles 2 and angle 6. We've got angles 4 and angles 8. And we've got angle 3 and 7. Okay. And once again, we've got a theorem for it. It is called the corresponding, and I'm going to abbreviate that, corresponding angles theorem. And that tells us that corresponding angles are congruent. So corresponding angles are congruent. Okay. Next we've got consecutive interior angles. Okay, now we're back to that language of interior exterior, so I should be looking in the interior inside my parallel lines here. And consecutive interior angles are inside the parallel lines and on the same side of the transversal. So if I were to look at my diagram that I drew in my video here, and let's take let's try a bright green color. We know they have to be interior, and so this angle, I don't know if it's really working, this guy and that guy, that's poorly done, are consecutive interior angles, okay? You'll also sometimes hear this called same side interior angles. Either one is okay, so I'm going to write that over here, same side interior angles. Okay, so if you like this one better, I'll take it. Our examples here, we've got angles 3 and angles 5, and angle 4 and angle 6. And we have a theorem. Now you guys should know, you should be looking at those angles. I'll maybe blow it up a little bit here. This angle right here and this angle right here are not congruent, right? We even marked it in there. Any ideas on how those are related? Well, we do have a theorem. So again, consecutive interior angles theorem tells us that those angles are supplementary. I might need to write this down here. Consecutive interior angles are supplementary. Supplementary. Okay, that goes up there. Okay. So supplementary. Ooh, I hope we know that word by now. Supplementary right here means that they add up to 180 degrees. Okay? So maybe make that note if you're not quite comfortable with that. Alright, next we've got vertical angles in linear pair. These are the last two we're going to talk about. You guys should already know these, but we can still make sure we know them. So vertical angles are angles that share a vertex and are formed by two intersecting lines opposite of each other. Okay? And we have lots of examples of those here. We've got angles 1 and angles 4. We've got angles 2 and angles 3. We've got angles 6 and 8. And we've got angle 6 and 7. Wait, 6 and 8. 5 and 8. Sorry about that. 5 and 8. And 6 and 7. Okay. And you guys already know the vertical angles theorem. That says vertical angles are congruent always. Okay, doesn't have anything to do with parallel lines. And then linear pair, adjacent angles that form a line. So these are, here's a line, here's two angles, this angle and this angle are a linear pair. I've noticed some students have said, okay, I've got this angle going up here, and then like let's call this guy going off this way. This guy and this guy are a linear pair. No, they have to form a line. So if I look at my diagram, let's go with the blue. I could do this angle right here and this angle right here are a linear pair, and this angle right here and this angle right here are a linear pair, but I can't take a blue and a purple together. Okay, so just keep that in mind. And let's see, we've got tons of examples here. I'm just going to go through a few of them. So here's angle 1 and angle 3 are a linear pair. Angles 6 and 8. There's tons of them here, so I'm not going to go through all of them, but you guys get the idea. 7 and 8. Okay, notice I need to list 2 of them because it is a pair after all, right? So those are some of my linear pairs. And linear pairs are supplementary. Okay. So those are our big ideas for this unit and what we're going to use throughout the unit. So make sure you got that vocab down and you're able to talk about them and use those theorems, because that will be all very important throughout the unit. Alright, we'll see you guys tomorrow.